Okay. Starter. Let's try these.
A is 3.7.
Yep.
B is just 320.
Yep.
C is 8.5.
Yeah, I think you'd say it as 8.50 just to show it's two decimal places.
All right. D is 15.7.
That's it. Great. And so let's try these.
Each measurement smallest possible value. Smallest possible value. Would it be 35.5?
Yep.
100. Centimeters. 111.5.
0.5. Yep. And okay, how about B?
One decimal place. 2.45 and 6.65.
That's it. And how about this discussion question?
What is the largest possible value that rounds down to 6? Would it be 30, 36.5?
So yeah, even though 36.5 would round up, that's like the boundary.
Yeah.
It's around the boundary. And this is how you would deal with that boundary problem. So you just say this is or equal to for the lower bound, and it's not or equal to for the upper bound. Okay, so how would you write 18 as an inequality? It was rounded to the nearest meter.
So write it like it shows up there.
Yeah.
It would be 17.5 one and then thing and then X and then 18.5.
That's it. And so it can't be 18.5, so that's not included, but it can be 17.5. That would round up, so that is included. Okay, B.
24. 24.44.
Close. 0.4.
Oh, 45.
Yeah.
And then 24.55.
24.55. You have X in the middle. And what's the difference between these two?
That one is the line underneath it, one on the left.
Yeah. And that one doesn't. Well done. C.
1.4 to 1 decimal place. Be 1.35 and 1.45.
Yeah. And that's the same. And D.
5.25.
If this is two decimal places, so it would have to have an extra decimal place.
5.255.
Yeah.
And then 5.265.
6, 5. Great. Any questions about those? So this is lower bound, upper bound. Let me just see. One decimal place. Only one that is different looking to me is E.
E.
So same thing before E.
5,000 meters to one significant figure. Would it be 4,500
Yep.
and 5,500?
Well done. That's great. Okay, exam question.
Machine plus strings cost 100 copper station liters, correct inverse 0.5. So, would it be?
And let me, well, this is what will always work. Because you have to do like half above it and half below it, it's always the rounded value plus or minus the degree of accuracy.
Oh, right.
Oh, sorry, half the degree of accuracy. Yeah, half the degree of accuracy. Okay, so they want the lower bound for this one, so it'd be the minus one taken away.
So it would be, lower bound would be it'd be 299.75.
Well done. And that's milliliters. 199.75, is it? Yes.
Wait a second, let me write that down. Need a pen.
Okay.
All right.
Okay, that was that. Okay, let's try this one.
Value of P is 4.3. Value of Q is the nearest 0.1. So it would be 4. It would be 4.25.
Yep. Okay.
Sasha drops the ball from a height of 2 meters onto the ground. Time seconds that takes the ball to reach the ground. D is 3.5. Correct 3 significant figures. 5 correct 2 significant figures. Alright, would it be a 35.5? 35.55.
5.55. There we go. So lots of stuff going on. And so what would you give yourself for the... Let me just check.
6.
Yeah, that's the 1 markers. What's this? Okay, let's try this one.
The length of the square is 5.34 to 2 decimal places. The upper and lower bounds. The 5.335 and 5.345. Degree of accuracy would be correct to 0.005.
Okay, so they didn't want the length, they wanted the perimeter of the square.
The perimeter. Uh, so it would be times by 4.
Yeah, and this is calculated.
All right. 21.34. 21.38.
Okay. That's it. Give the perimeter to a suitable degree of accuracy.
All right, will be
I think that's all right. Is it?
0. Oh,
Ah, so they said they settled on 21 because that's what they both. Let's see. So 21.3. That would round to 21.4, but they both round to 21. Let me just see what the thinking was here. Yeah, round the upper lower bounds to 1.place 2. They give the same value. No. Round to the nearest centimeter. They both give the same value, so we can be sure that to the nearest centimeter. Ah, okay. So we can be sure that the perimeter is 21 to the nearest centimeter. Yeah, so this is a rounded value. So the lowest it could have been was this. The highest it could have been was this. The lowest the perimeter could be is this. The highest the perimeter could be is this. But we can be certain that the perimeter is 21 centimeters to the nearest whole number. Nearest whole number. Okay. Any questions about that? Okay. Okay. All right. Let's try A.
Rectangle measures 15 by 28 centimeter. So the length would be 14.5 and 15.5. And the width would be 27.5 and 28.5.
Okay.
Calculate the upper and lower bounds for the perimeter of the rectangle. Give the perimeter to a suitable degree. So it would be those two added together times by 4.
How many sides? That'd give you 8 sides.
So just 2 of them.
Yeah. So those two added together times 2.
Or times 2. All right. $797.5. So the other one would be 798.5.
And calculate the upper lower bounds for the perimeter, and then suitable degree of accuracy.
I guess they both round. Oh no, they don't round up to. Correct to the nearest 0.5.
So they're two different numbers. So what would it be if you rounded it to two significant figures?
Two significant figures. It would be 800.
So they'd both be 800, I think, would they?
Yeah.
And so that's what they agree on. So it's the perimeter is 800 centimeters to two significant figures.
So is it always to two significant figures?
No. It's just the thing that it agrees on. So at the moment we have four significant figures. We have four figures, but they're two different numbers. If we rounded it to 3 sig fig, which is the same as one decimal place in this case, we'd get two different numbers again. We'd get 798 and 799. So 4 figures, they're different. 3 figures, they're different. 2 figures, they're the same.
Oh yeah,
And so
I
that's
understand.
yeah, we can say it's definitely now in this case it happens to be that 2 sig fig and 1 sig fig give the same number, but just because it was very close to 800. But yeah, once you try to make it as accurate as possible, but once you hit it so they're both the same, then we can say the perimeter is definitely 800 to 2 significant figures. So we can't. They gave us rounded values, and so we can't be certain, but we can be certain to 2 sig fig because they both give the same regardless. Any questions about that one?
No.
Okay, exam question. That was your previous correct answer to part A, and then they give part B. So I'm not sure if you need part A to do part B, but I put it in there.
The machine puts tea and milk into each cup. Puts 175 tea to the nearest and 24. So is it possible that the total volume of tea and milk put into a cup is greater than the cup? So what should I find? Should I find out the higher bound? See if it's over.
Try that.
All right. So higher bound for 24 would be 24.5. Higher bound for 175 would be 175.5. I think that would make 200. So I guess not.
Let me see the volume. The machine. Aha, so why not?
Because it's not greater. It's just the highest it can get is the same as 200.
But 200 is rounded. What's the lowest the cup can get?
The lowest the cup can get is what's it called? 100, 199.5.
0.75.
Oh no, 199.75. Yeah.
And so is
So
it?
yes.
And so yes, it is technically just possible. Yes,
Yeah.
if you had the higher bound of the these two
Yeah, the lower bound of the cup.
and the lower bound of the cup, then yeah, or something in between. So yes, and so you've got 200 written somewhere, and you make that comparison. 3 marks. Any questions about that?
No.
Okay, and we're gonna use this idea more in a minute. So 3 marker, that stuff. What do you give yourself?
6 actually.
Yeah, so that's perimeter and all that stuff. This gets weird. Okay, how would you find the upper bound for? Very clever.
In the diagram, the lengths of AC and BC are given correct to the one. So find the upper bound for AC and BC.
Let's just skip to part B. How would you get the upper bound for X?
Upper bound of X. It's Pythagoras.
Mm-hmm.
So you would find the upper bound of AC and BC.
Yeah.
And then you would square them. And then you get the upper bound of AC and BC, square it.
Yeah, and then square root your answer.
Yeah.
How would you do D?
Use part C for it. You would just find the lower bound.
Yeah, and so it'd be the square root of, I think, 8.55 squared plus 7.35 squared.
Yeah.
And that would be your answer. Okay, that's fine. Nothing special there.
Find the upper bound, the lower bound of y, and the upper bound, the lower bound of z. Count the upper bound of x, work out the
So
lower bound of x.
how would you do C?
Well, you would find the upper and lower bounds of y and z, then times the upper bounds together and the lower bounds together.
Yeah.
I mean, yeah.
And for D it would be the lower bounds. Yeah, that'd be all right. Okay.
Eventually, a cuboid of 5 by 3 by 8 measures in the nearest centimeter. Calculate upper and lower bounds for the volume of the cuboid. So what would the volume be? Is it then we'll times together?
Yep.
All right. So upper bound of the upper bound of 8 is 8.5. The upper bound of 5 is 5.5, and the upper bound of 3 is 3.5. So you would times all of them together to get the upper bound.
And what would you get? How would you do lower bound?
You would do the same for the lower bounds. Lower
Yeah,
bound of 5 is.
I think you'd be fine for this. Yeah. I think you're good. You just put in the calculator. You're all right. So yeah, then that would get you the thing for the volume. So this is why you wanted to do this topic. This is why it's quite a kind of revision type of topic, because you can do a bit with everything. So do you remember how to do A?
Arc length and area of the sector. Did we do sectors, or am I just remembering it from school?
You might be remembering it from school.
Maybe we should do sectors later then. But work out the arc length and area of the sector.
How do you find the area of a circle?
Area of circle, pi times radius squared.
And what fraction of a circle do we have here?
200, 406.
200 out of
360, so the extra will be 160.
And so this is.
We have 2/3. Do we?
I don't know.
No.
It's all the same to the calculator. What's the radius?
The radius is 7 centimeters.
Yeah. So that would give you the area of the sector. How would you get the upper bound of the area of the sector?
The upper bound of the area of the sector, you would. I should do the thing first. It's 8.55. So 85.5, sorry.
Okay.
85.5, and then so you would do the lower bound would be 85.45, and the upper bound would be 85.55.
Doesn't work that way. Otherwise, we could have done that with everything beforehand. We could have just done 5 times 3 times 8, and then just. It's not the volume that was rounded; it's these lengths that were rounded. So we unrounded them. This one, area wasn't rounded; the radius was.
I'm a bit lost.
Radius. What is the upper and lower bound for the radius?
7.5 and 6.5.
Yes. And so how can you use that to get the upper bound for the area?
Did you times them together?
You would find the area, except you wouldn't use 7.
So find the area of out 7, so it'd just be 200 out of 360 times pi.
It has to be times the radius squared. What's the biggest the radius can be?
Times 7. Oh, I understand now, yeah. Times 7.5 squared.
And so how would you get the lower bound for the area?
Oh, it'll be times 6. It'll be the same, but times 6.5 squared.
Well done. Yeah. Because the area wasn't rounded, the radius was rounded, and so we just unrounded it. You've already put this into your calculator, so I know you're good with calculator, so you know. Any questions about that? Okay, so that I'm just kind of focusing on the important bit. Okay, upper and lower bound of the volume. Do you remember the volume of this thing?
Not really.
I believe
Oh,
it
it's
is.
square. A triangle is like half a square. So like, would you find the volume of the square first and then half it?
You find the volume of the cuboid and
Yeah, yeah.
third it. Believe it or not,
Oh,
it is one
right.
third length times width times height.
Okay. So it would be wait, yeah, a third of. So would you find a third of 8.4 and 8.4 and 6.9?
You would do well for the volume. You would do one third times 6.9 times 8.4 times 8.4. So if I just go back a second, I told you this was a revision topic. Oh, do I have to go? I thought we had a picture somewhere. Did we not? We found the volume of a cuboid a second ago. Yeah, so this one you have a cuboid 538, 538. Looks something like that, except better. If you had a like pyramid inside that thing, you would do so the volume of this is 5 times 3 times 8. The volume of the pyramid inside it would be 5 times 3 times 8 times a third. So your answer times a third. And
Oh, right.
And so this one is same idea. It's 6.9 times 8.4 times 8.4, and then just times a third. Like this could
All
make
right.
a cuboid. It could be like a pyramid inside a cuboid.
So what would you find the upper bounds of 6.9, 8.4, and 8.4 to find the upper bound?
Correct. Yeah.
All right.
And so what are the upper bounds?
The upper bounds would be a third times 6.95 times 8.45 squared.
Well done. And so that would give you the upper bound for the volume. And lower bound for volume?
A third times 6.85 times 8.35 squared.
Well done. Any questions about that?
No.
Okay, exam question.
Is formula area equals this triangle 7.8 correct to nearest millimeter, 5.2 correct to nearest millimeter, 63 connects correct to the nearest degree. So okay, so it would be area equals half AB sine 3 C.
Mm-hmm.
So it would be half half 7.8 times 5.2 sine 63 degrees.
So that would be the area, all right. They wanted the lower bound for the area.
Lower bound, it will be half 7.75 times 5.15 times sine 62.5.
So try putting that into your calculator.
Times. Should I close the bracket for the sine?
It'll automatically do it. It'll get the same answer.
17.7.
17.7 millimeters squared. 17.7. There we go. 3 marker. Any questions about that one?
Nope.
Okay. Okay. How about this one?
Let's cover a triangular field. Fertilizer. ABC equals 50 degrees, correct the nearest degree. So BA is 225 meters. BC is 175 meters. So we need to find angle ABC. So what would it be? If angle B is 50, angle A and C would be
how did you just find the area in the previous question?
What's that formula? That's like half AB sine C.
That's it.
Half. Oh no, we don't have the angles.
You only need one angle.
50.
What is A? What is B? What is C?
A is A equals 180, but I'm not sure what it is.
How'd you get 180?
It's that's all the angles on a triangle.
Side A for our formula.
What?
You just did this. A half AB sine C. A half times side times sine angle between.
I mean sides. All right. Half. I'm in angles. Half. 225 times 175 sine. So what would C be?
The angle between them.
The angle between them. Oh, 50.
That's it. Okay, they want the upper bound of the area.
So half of 225.5.
Nearest 5 meters, not nearest a whole number.
Oh, half 225 point
Plus half the degree of accuracy.
oh plus half the degree of accuracy plus. Oh yeah, no. Half 225. I mean half to half to 7.5. I mean 227.5.
Yeah. Go on.
I'm just filling in the calculator. Times 1775.
Well done.
No, 177.5 times 50. I mean, sine 50.
Upper bound.
Oh, sine 50.25. I mean, 52.5.
That would be if the angle was also rounded to the nearest 5
Oh, it's
degrees.
the nearest degree, sorry. Sometimes I don't really read the question properly.
I've noticed.
Uh, 100, 15,579.6.
What angle did you put in?
I put in 50.5.
Well done. 50.5. And what was the answer?
15,579.6.
0.6. That is meters squared because it's area. So anything between 15,500. Okay, great. And so a half times 227.5 times 177.5 times sine 50.5. Great. Any questions about that one?
No.
So they want upper bound. Okay, that stuff.
I'd say tick.
That's easy. That's just the start there. Here they have it written on a number line. It's the same idea. Same idea. 22.5, 23.5. So that's just as a number line. Yeah, that's all right. Okay. I want to focus on this thing. I might come back to this. Give you a real example first. Yeah, let's try this one. Hang on, let me see if there's a more straightforward example to begin with. You think that would be? Wow, there really isn't, is there? Why do I have to make stuff up? I'm gonna say A is equal to y minus z. What is the what is the upper bound of A?
Y is 1.2 to 1, so it would be 1.25 would be the upper bound of Y.
Mm-hmm.
And it will be 0.45 the upper bound of Z.
Okay.
So we would time on a Y minus C, so it would be 1.25 minus 0.45.
So 1.25 take away 0.45. So what do you get for that?
0.8.
Is there a different selection of numbers that will give you an even bigger number?
Oh no, that was the upper bound. So
Try the upper bound of y, take away the lower bound of z.
uh, so 1.25 minus 0.35, 0.9.
That's it. So that's bigger. And so that's the upper bound of a. And so when you're adding and multiplying, it's just lower bound, upper bound, upper bound. Whereas when you're subtracting, we did the biggest it could, the biggest value y could take away only the smallest value that z could take. Technically, z could be 0.35. So maybe now I'll go back to this thing. So what would be question B for this one? How would you get the lower?
Oh, z equals x plus y. With b,
Yeah,
it would be
if you were trying to get the lower bound for z,
the lower bound. C.
z
It
is
would be the the it would be the lower bound of x minus the lower bound of y.
you can make it even smaller.
The lower bound of x minus the higher bound of y.
Yes. How about question D?
Divided. So it would be the the lower bound of x divided by the higher bound of y.
Well done.
What would be different?
Yep, that's it. And then if you want the upper bound, you just swap them. The upper bound of x take away the lower bound of y. So similar to the question we did, like the biggest number, take away the smallest possible number so that you can be left with as much as possible. Same with dividing. So with adding and multiplying, it's just like lower bound, upper bound, upper bound. Whereas with these two, it's different. Lower bound, upper bound, lower bound. So let's try this one. Okay, so let's try C. We want x, and x is y divided by z. The lower bound of x. Sorry, upper bound